Right. So what we're going to do is we'll set up the calibration signal on the scope again. Okay. And then we're going to have a look at the Sig Gen and what comes out of the Sig Gen. And we're going to set up a matching signal from the Sig Gen, or as close to a matching signal as we can get. We can't get 100% there, and I'll show you why in a minute. Okay. So on the scope, just to go back to the scope for a second, I'm going to hit Save Recall and Default Setup, and that brings me back here. I need to start again from scratch. Okay, so I'm going to turn off channel 2 because I don't want to see that for the moment. Okay, and then I'm going to select channel 1. I'm going to couple to ground. So I didn't talk about coupling a whole lot there a minute ago. Okay, but I'm going to couple to ground. Coupling to ground means that there is now a 0 volt signal on my channel 1. Okay, and the reason I want to do that is just I bring that trace then to where I want it on the screen. So I'm going to start with the center of the screen. Okay. And the other options we have in the coupling are DC and AC. Okay. If I couple to DC, then the scope will allow in any DC or AC signals. Okay. If I couple to AC, the scope will allow in any AC signal, but will block any DC signals. Okay. And I'll show you an example of that when we have the scope set up, or the Sig Gen set up. Okay, so AC allows AC only, DC allows AC and DC. Okay. So we're going to go back to DC because it's a DC signal we're putting in here. Okay, I'm going to take my probe. Okay, I'm going to hook it up to my test point here. I'm going to connect my 0 signal. I'll keep my probe up here out of the way a little bit if I can. Connect on there. There he is. Okay, and now I need to find my signal. So I can see there's a signal there because it's jumping up and down all over the place. Okay, a signal that jumps up and down like that and is a little bit erratic is normally a good indication that it's the time base that I need to adjust here. Okay, so currently my time base is 2.5 seconds. Okay, in the manual it tells me that the frequency of this test signal is 1 kilohertz. Frequency is equal to 1 over the time period, or the time period is equal to 1 over the frequency. So if my frequency is 100 hertz, my time period is 1 millisecond. Okay, so 1 millisecond wouldn't be a bad aim to have on the time here. Okay, so we head out there and go to 1 millisecond. So 1 millisecond per box here, and that's roughly where my signal is sitting there. It's a bit jumpy at the moment, but we'll figure that out in a second. Okay, ideal signal setup: 2 peaks, 2 troughs, and as large as I can without chopping the signal. Okay, so the 2 peaks and the 2 troughs refers to the horizontal. Okay, so I set up my horizontal so I see at least 2 peaks, 2 troughs. Can't see it, it's jumping all over the place. So to get the signal to sit stationary on the screen, okay, is my trigger. Okay, and you can see here where my trigger is, it's yellow, that means I'm triggering off channel 1. Okay, it's at the bottom of the signal here, so if I bring it up a little bit, maybe it might trap my signal. There we go. Okay, now I've got a signal in there. What I have now is 1 trough, 1 peak. Okay, so we're back in my time base, and now I have 2 peaks, 2 troughs. Remember, at least 2 peaks, 2 troughs. Okay, but not 15 of them. Okay. I want to make my attenuate to make it larger, vertically. Okay, because I want it as big as I can without cutting it off. Right. At that position, I haven't cut it off. It's at the top of the screen, but I'm not sure if there's actually anything above it or not. Okay, so I'll come back here to this one. Alright, now I can see top, bottom, 2 peaks, 2 troughs. Okay, and then from there, actually, never checked my probe. I'm in 1x on the probe, so I'm going to go to 10x. Okay, so 10x on the probe for calibration. So I need to attenuate again to get my 2 peaks, 2 troughs, which is about there, and my trigger is way up too high. Because he thought I was looking for a 2 volt signal. Well, now I'm looking, because I've attenuated by 10, I'm looking at a 200 milliamp signal, millivolt signal. Okay, and now I'm going to adjust. So the adjustment is in here on this. Okay, and I get my in there somewhere. The pot's not great in there, is it? There we go. So over attenuate, over compensated, under compensated, and as flat as I can for just right.
What are you getting there when you get it when it's just right?
When you're getting it just right, what you're doing there is the coax cable that's in there. You've got the signal in the center, and you've got the outer shielding cable then, which is our earth in this case. Okay. At high frequency, we get capacitance effect between the two of those. Okay. That pot it's not a resistor. It's a variable capacitor. Okay. So we're adjusting an offset capacitor. Okay. So the capacitance we get between the signal and the shield is called a parasitic capacitance. Okay. It's one we don't like in the system, but it's there because of the nature of the cabling. Okay. So if we can put in that or trim an offset capacitor that balances it out. Okay. So we're negating that parasitic capacitance. Okay. And we're just getting our nice signal.
Okay. And would you need to tweak that every time you're doing the signal, or it's just the calibration of it at the start?
Just calibration with the probe at the start, and really, as long as you're not throwing the probe around and damaging the probe, you shouldn't have to do it again. As I said, it's a good practice just to go in and check it. Certainly for the next couple of weeks anyway, just go in and check it. Yeah, it's a good practice. Okay. So there's my signal. Okay. And we're after triggering. We've done vertical attenuation, horizontal attenuation. We've done coupling. Okay. Keep an eye on that one there. Make sure the probe is 1x here. Okay, because you can go 110 or 100x there as well. Okay. Once you've calibrated your probe, slip it back to 1x, because we measure in 1x. Okay, most signals. There's the odd occasion we'll measure somewhere else, but most cases we'll go 1x. And reset my trigger here. Okay. Now I've calibrated the probe for the second probe that's on channel 2 as well. Okay. So I'm just going to take this out of here for a second because he's blocking out my Sig Gen. Because I want to talk about the Sig Gen for a minute. Actually, if we can slide him back there for a second, toast away. Okay, so my signal generator or function generator, whichever way you want to do it. The scope reads the signal, the function generator creates signals for us. Okay, and we use those signals to test. Essentially, what the function generator uses is a testing function, gives us test signals that we can use. Okay, so the likes of the op amps that we've built, we're going to put in an AC signal into the op amp. Yeah, so remember the sine wave we had yesterday and we showed it inverted. Okay, so we're going to use the signal generator to generate that sine wave, put it into the op amp and see the inverted one coming out. Okay, and we'll be able to see both of them on the scope, hopefully. Right, so signal generator. Knock it on down the bottom here. I forgot to tell you that about the scope. The scope was on down the bottom. Okay, on the signal generator we have the display here. Okay, the display shows us the frequency and only the frequency. Okay, we have an adjustment here for the frequency, so we can vary our frequency up and down. Okay, you can see bottom right hand corner it says hertz, and if I go up in the frequencies it's now telling me kilohertz. Okay, you see the gate flashing up here. You can just ignore that for what we're doing here. It's got to do with transistor logic and transistor testing and stuff. We won't be using it for that. Okay, we have on the bottom row here we have 3 different signals that we can generate. We can generate a square wave, a sawtooth wave, and a sine wave. Okay, and then we have different frequency bands up here. All right. So if I go to the 1 kilohertz, which I have here, if I bring my frequency knob all the way down anti-clockwise, I can start at 10 hertz or 9.6 hertz. Okay, and the max I can go to is 3.3 kilohertz. Okay, and that range from 1 to 3.3 essentially runs through all the ranges. Okay, so it doesn't matter which range I select. The max min value is what change. The max min nominal numbers don't change, but the amplitude changes. So at 10 hertz now I have 32 hertz. At 100 I have 332 hertz. At a kilohertz I have 3.3 kilohertz. 33 kilohertz for that. What you did there, etc. Okay, so we have the frequency bands here, the actual frequency adjustment here, and then the type of signal here. Okay, 2 more things. Amplitude is going to set the amplitude of the signal, so 1 volt, 2 volts, 3 volts, etc. I think these things get up to just about 5.5 volts, maybe close to 6 volts. Okay, and then the output. There are 2 jacks here for outputs. This one is for TTL, CMOS, transistor logic testing. Okay, and this is the general output, the 50 ohm output. This is the one we will use. Okay, this one over here. To hook into it, we use this test cable. Okay, so it's got a BNC on one end, and it's just got 2 clips on the other end. Okay, not a scope lead, so don't use this one on the scope. This is for the Sig Gen to produce the signal. Okay, because there's no calibration that we can do on this one. Okay, so same type of connector in here, the BNC. Pop it in and rotate it until it locks in. Go on. Okay. And then we can hook our scope probe up to this. So I'm going to hook up channel 2 to this. Alright, so red is the signal. So I'm going to hook my scope probe to the red. And then black is the 0. So I hook my 0 hook in there. Okay. Bring the stat back out here a bit. Get it back into focus. Right. What have we got? Channel 2. Okay, which is the blue channel. That's my Sig Gen. Alright, already we can see there's a signal down here. Okay, so attenuate horizontal to see what's going on in there. And there we have our wave. I'm going to turn off channel 1 for a second, we'll come back to it. Okay, I'm going to couple, I'm going to go to channel 2. I'm going to couple it to ground. So I bring it up to the center of the screen. This one here. Okay, I'm going to couple to DC and AC. So there's no difference between DC and AC there if you look at the signal. Okay, but we'll change that in a minute. I'm going to attenuate the voltage on it so I can see more of it in here. Okay, attenuate the time so I get 2 peaks, 2 troughs. Alright, but you can see I'm not triggered. Okay, my trigger you can see here is still on channel 1, it's still yellow. So go to the trigger menu and hit source channel 2. Okay, and now he's up the top of the screen here so I can wind him down along. And there he is. Okay, and I get my sawtooth signal. 2 peaks, 2 troughs. Okay, if I select sine wave down here, I get a sine wave. And if I select square wave, I get a square wave. Okay, I can change the frequency over here. Okay, yeah, we'll bring it back in here and we'll attenuate the time in a little bit. So there's my frequency. Okay, and the amplitude is down here. This bottom corner here, so I can change the amplitude of the signal. That's actually the very minimum amplitude. So I'm going to bring up the amplitude a little bit, so it gives me room to go positive, negative on it, and then I'll attenuate this back in again. Okay, so now you can see that I can go up or down on my signal amplitude. Okay, there's no way to measure the amplitude using the Sig Gen itself. Okay, so for some of the stuff we're going to get you to do, we'll do RMS voltages. And we can hook the 2 leads up to the multimeter and we can measure the voltage on it. Okay, or we can measure it on the scope here itself. Okay. So what I said we were going to do is we're going to take the calibration signal from channel 1 and we're going to match it on channel 2. Alright, so I want the 2 signals on the screen at the same time. So channel 1, I need to hook back up my probe to the test signal and my 0. Okay, I'm going to go back and trigger off channel 1 for a minute. Channel 1. Okay, I'm going to bring my signal in. I want 2 peaks, 2 troughs. 2 peaks, 2 troughs. Okay, so the yellow one is my calibration signal. I want to match that with the Sig Gen. Okay, so I want to match. I can see. First thing I need to make sure that my volts per division is the same. Okay, just make sure I'm in one there. Yeah, so I have 500 millivolts on the channel 1, which is my reference signal. So I'm going to go to 500 millivolts for channel 2 to match it. Okay, now I can see that signal's way off the screen, so I need to attenuate the amplitude. So I bring the amplitude down, and that's roughly about right there. Okay, the other thing I can see is way off is the frequency. Okay, so at the moment I have 12 kilohertz here. Right, so I'm going to adjust my frequency to match it. Okay. Yeah. Now, because my frequencies are slightly different, my trigger won't hold both signals. Okay, because it's triggering off the frequency of the repeating signal on channel 1, and because the frequency on channel 2 is slightly different, it doesn't see that channel as being the same. Okay, so let me go back here to measure. Okay, so measure up here. If you look at the frequencies, channel 1 is 100 hertz. Sorry, channel 1 is a kilohertz. Channel 2 I'm going to match as close as I can to a kilohertz. Okay. 1.6 there now when we drop it back down. And getting close. Okay, but you can see the blue one is still traveling. Okay, and to me it looks like the blue one is traveling from right to left. Does it look the same to you, or sometimes it's an optical illusion when you can't figure out which way it's going? It's going slightly right to left, and if I adjust this, you can see it stops and it goes back the other way. Okay, that's just because of a slight shift in frequency. Okay, if I hook channel 1 to this signal here, okay, then they're locked on top of each other. Okay, and because they're at the same frequency, the trigger will hold both of them. Because they're not at the same frequency though, and it has to be fairly perfect to hold it. Okay, but there's a matching signal. Okay, I'm pretty close, or as close as I can get to the 100 or 1000 or 1000 hertz, 1 kilohertz. Okay, I'll get a little bit better than that, I think, can we? Not that far. Come back. They are fairly delicate. If I go down, I'm actually sorry, I'm in the 10 kilohertz range here. Okay, so I don't have anywhere near the sensitivity I want. Right. So if I go to 1 kilohertz, I'll get more sensitivity. It'll allow me to get closer. Okay, that's not bad. 1003. But you can see it's still traveling. Okay, my voltage, peak to peak voltage, I can see here. I can match them here, and that's really all I want to know: the voltage and the frequency. Okay. So Sig Gen generates a signal, and I can change this. If I do something down here, I'm changing the signal. Okay. If I do it up here, I'm just changing the way I view the signal, not changing the signal. Okay. One last thing I wanted to show you before I let you loose on your own once again. I'm going to turn off channel 1. I'm going to re-trigger off channel 2. Okay, so there's my channel 2 signal. Bring down the amplitude a small bit so you can see it there. Okay. Coupling. So AC coupling allows AC only true. DC coupling allows DC and AC true. Okay. Some of the knobs on this guy here, you can pull them out and it engages them. Okay, and you can see the descriptions on the bottom here. But one of the ones that we will look at is offset. This one here. Okay. If I pull that out, it injects a DC offset. Okay, so it puts a DC signal in on top of the AC signal, or in with the AC signal. Okay, and if I adjust it here, you can see that the signal deviates, but then it comes back to me. Okay, it recenters around 0. That's because I'm AC coupled. It's blocking all the DC. If I go and I couple to DC, you can see my signal has dropped down, and if I adjust my DC now, you can see the DC being injected into it. Okay, so that's an AC signal with no DC because it's centered around the center line, which is here, the 2. And if I put DC voltage in, so that's gone up a division there, so that's plus 500 millivolts DC I'm after adding in. Okay, if I go back to AC, it recenters. Okay, so I block that DC. We are going to be doing some DC blocking with our circuits. Okay, how do we block DC? Capacitor, yeah. So the op-amp circuits that we have, we're going to be putting an AC signal in there, looking at a sine wave. Okay, and we'll be putting capacitors on it so that we don't get the DC back out there. Okay, so we will be doing some of that. Right, questions on the Sig Gen? No?
You know, when you're changing the frequency on the top, on the oscilloscope?
Yeah.
Yeah, how did you do that again, sorry?
To change the frequency?
No, you know, what you're reading of the frequency.
Yeah, so go into measure.
Yeah.
In here, is it?
Yeah.
Okay, and to get the measure,
Yes.
the frequency measure here. So if you'll have some selection here, or it might be all off. We'll go to the bottom on here, rise time. If I press on the soft key beside it, okay, and then select the middle soft key here, it gives me this menu, and then using the variable knob, I can select whatever I want. So it will select frequency, okay, and then press time frequency, and then previous menu, and now you can see frequencies in the measure down here. Okay, and I can put whatever measure I want in there. Generally, we're going to be looking at V peak to peak, VRMS, and frequency for most of what we're doing. Any other questions? No? You all happy? Right, what we're going to do so is, as I said, use the lead from your monitor, power up the Sig Gen, and I want you to set the Sig Gen signal to match the calibration signal like I was doing there. It will scroll across the screen unless you can get a perfect match in the frequency, which is it's kind of hard to do. Let's see if I go back down here, I might get it any closer. I have to put channel 1 back on. I have to put my probe back on. Bring this frequency up to a kilohertz. I can't get to a kilohertz there yet, so I can't get any closer. Okay.
Where's that signal coming in again? Where are you taking the signal from the signal generator?
From here. From the signal generator output is here.
Yeah.
Okay. To these two leads.
Oh yeah.
Yeah, and then I'm hooking my scope up to those two leads and into channel 2.
Yes.
Yeah, so blue scope.
Channel 1.
Yeah, so channel 1 is on the calibration, channel 2 is on the Sig Gen for me. Yeah, it doesn't matter which way you have them. Okay. So before you start, hit save recall, default setup, and go from there. Okay. Get your calibration signal and then set up your Sig Gen to match it.